Hey everyone, and welcome to The Explainer. Have you ever talked to an AI and just been floored by how it seems to get not just what you're saying, but what you mean? Well, you've come to the right place. Today, we're going to pull back the curtain on the secret language that makes all of that possible. It's an incredible piece of tech called vector embeddings.
I mean, really think about it for a second. You ask a chatbot a question, and what comes back is surprisingly human. How is that even possible? How does a machine, something built on pure logic and code, actually grasp the subtle meaning and the context behind the way we talk?
Well, here's the secret. It's not some kind of unknowable, magical black box. It's actually something way more elegant and honestly pretty intuitive once you see it. It's math. Yep, it all comes down to the beautiful, powerful math of meaning itself. All right, let's get into it. You see, for an AI to make any sense of our world, our words, our images, our data, it has to first translate all of it into a language it can actually work with. And at its core, that language is all about numbers. This is the AI's secret language, and it's the foundation for everything else we're going to talk about.
So at the very heart of this language is something called a vector embedding. Now, the absolute best way to picture this is to think of it like a set of GPS coordinates, but for meaning. Instead of mapping a physical location, this process takes a word or a sentence or even a whole document, and it plots it as a point in this huge multi-dimensional meaning space. The result? A long list of numbers. That's the vector, which numerically captures not just what something is, but how it relates to every other concept.
So the process itself looks pretty simple on the surface, right? You take some raw data, let's say it's a huge PDF, like a company's annual report. You feed that into a special embedding model, which is basically our expert translator. That model reads the whole thing, understands the concepts, and then spits out that numerical vector we were just talking about. This simple data in, vector out pipeline is what gives an AI its incredible power to understand.
But here's the thing. Just like translating from one human language to another, creating good embeddings is a real art. It's not just a mechanical process. You have to make some really smart, strategic choices about the tools you're using, because believe me, not all embedding models are built the same.
Yeah, picking the right embedding model is all about trade-offs. For a lot of everyday stuff, a balanced model like mixed bread is perfect. It's like your Swiss Army knife. You can even choose different sizes of vectors, so you can trade a little bit of precision for a lot more speed and lower costs. But if you're trying to analyze, say, complex medical documents, you need a specialist, an LLM that's been trained specifically on that kind of knowledge. And what if you're dealing with super sensitive company secrets? You're not just going to send that to the cloud. That's where you'd use a local model with a tool like Llama to keep everything safe, secure, and cheap, right there on your own hardware.
Okay, so we've done the hard work. We've translated our data into these super powerful numerical vectors. But now what? They can't just hang out in digital limbo. They need a place to live. And this brings us to the next critical piece of the puzzle. We have to build the AI a long-term memory.
And this is exactly where the old tech just fails. Your traditional database, think something like Postgres. It's like a perfectly organized filing cabinet. It's fantastic if you need to find something with a very specific label, like find me employee ID number 54. But it's completely useless if you want to ask it, find me all the documents that have a similar vibe to this one. For that, you need a totally new kind of database, a vector database. Systems like Ups-KV are built from the ground up just for this, to store and search billions of these meaning coordinates at mind-blowing speeds.
So what do you get with this special new design? You get speed. You get the power to search huge, messy datasets, not just by a keyword, but by an idea, and get an answer back in milliseconds. This isn't just a nice-to-have feature. This insane speed and scale is what makes AI feel so responsive and smart. Honestly, vector databases are the true unsung heroes here. They are the essential backbone for all the powerful AI systems we see today.
Which leads us perfectly to our final section, where we put all these pieces together. We've got the embeddings that capture meaning, and we've got the vector database that acts as the AI's memory. So let's see how they work together to create a much smarter search, and in the end, a much better AI.
The star of this show is a technique with a great name, Retrieval Augmented Generation, or just RAG for short. And the whole idea behind it is to stop an AI from just making stuff up, or what we call hallucinating. Instead, RAG forces the AI to first go and retrieve relevant facts from its knowledge base, our vector database, before it even tries to write an answer. You can think of it like giving the AI an open book exam. It has to show its work.
And look, this is not some fringe experimental idea. This is quickly becoming the gold standard for building reliable AI. The research firm Gartner predicts that by 2026, there will be over 25 billion autonomous AI agents out there in the world. Just think about that number. A huge number of them will rely on RAG to make sure they're being factual, trustworthy, and actually helpful.
So let's trace a single question all the way through this system. Let's say you ask your AI, what were our biggest growth drivers last quarter? The system doesn't just guess. No, first it turns your question into a vector. Then it searches the database to find the most relevant chunks of data from all those financial reports. And only then, with those verified facts in hand, does the AI generate its answer. This retrieve first, then generate process is what keeps the answers grounded in reality.
Now, of course, getting this right in the real world means you have to do a lot of fine-tuning. It's about optimizing for what developers call recall. You have to answer tough questions like, how big should the chunks of text be? If they're too big, you get a lot of noise. Too small, and you lose crucial context. How many documents should the AI look at to answer a question? How do we read the relevant scores to make sure it's only using top-quality facts? These little details are what make the difference between a pretty good RAG system and a truly great one.
So what's the big payoff for all of this technology? It's a complete revolution in how we get to information. As one source put it, this lets you replace multi-day BI projects with on-demand conversational queries. I mean, just let that sink in. A task that used to take a whole team of analysts days of work can now be done in seconds. All you have to do is ask.
So in the end, vector embeddings and RAG are turning all of our static, boring data, our reports, our manuals, our spreadsheets, into a living, breathing conversation. The wall between us and the knowledge we need is just dissolving. And that leaves us with one final, very powerful question. If any data can become a conversation, what will you ask? Thanks for tuning into The Explainer.